So how did BFO start? It started from the Gene Ontology. So the Gene Ontology has three ontologies, as I'm sure everyone knows. Cellular component, molecular function, biological process. So we re-engineered Go. Cellular components are what we call independent continuants. Molecular functions are what we call specifically dependent continuants. And biological processes are what we call occurrent. So this is the top level of BFO. Independent continuants are things like people, planets, tennis balls, molecules, cells. Specifically dependent continuants are things like quality, your mass, your height, your temperature. And occurrents are processes and the beginnings and endings of processes. And then we have spatial regions, which are independent continuants, and temporal and spatio-temporal regions, which are occurrents. So this is a slightly more detailed view of the top level. All of the arrows there are is-a relations. So every occurrent is an entity, every independent continuant is a continuant, and so forth. And then what people do is they build an ontology by importing BFO into Protégé and then starting to populate their new ontology by building downwards by defining subclasses of Protégé classes. And that methodology has been used now by hundreds of people, saves a lot of time, it guarantees a certain degree of interoperability with other ontologies, and it guarantees that you will have people who understand what you're doing on the outside who can tell you when you make mistakes. That is contrasted with SNOMED and with other big medical ontology-like artifacts, which are based upon something which people were pleased to call the concept orientation. Studies have shown that the approach taken by the Gene Ontology, the Obo founder, and BFO, which is the realist approach, is now gaining ground. That by some measures, it's already more popular than the concept orientation. I won't say much about this concept orientation, but you can see already that there is a certain problem here. So this is one old view of a simplified part of the SNOMED. Is a hierarchy, and you see that the physical object, according to SNOMED, is a concept. That is wrong. The physical object is not a concept. A disease is not a concept. If you have a headache, you are not suffering from a concept. Now, SNOMED has realized that there is a problem with this picture, so it issued a kind of health warning. Note that the word concept has three different meanings, and then it explained those three different meanings, one of which was indeed the meaning of concept, and then the other two were quite different meanings. One of them was code, and then the other one was something like class or universal. But they still use the word concept as the top-level term in their ontology. Tom Gruber and many, many successors of Tom Gruber, up to and including SNOMED, believe that the way to build an ontology is to work out the concepts in your head or in the heads of your expert friends, and then document them in a hierarchy. Now, we don't think that is the way. We think that that leads to mistakes because everybody has different concepts in their head. And anyway, who knows what's in people's heads? So what we say is the way to build an ontology is to work out what reality is like. Basically, an ontology, for scientific purposes anyway, is the terminological skeleton of a scientific theory. So the way you know how to build your ontology is to look at what scientists say. That's the way Gene Ontology was built. It was built by extracting the terminology of molecular biology. The Oxford Dictionary of Molecular Biology played a role in the building of the Gene Ontology. And if you're dealing with non-scientific ontologies, then you extract the terms you need from authoritative sources of documentation, such as, for instance, legal documents. Laws are a source, an authoritative source of knowledge, not about data, but about the legal entities which legal data are about. If you start with data and if you start with concepts, you will will likely end up with an ontology silo. If you start with the things in the world which the data that you have or are interested in are about, then you have a much better chance of having an ontology which is reusable and sustainable. All right, so that's realism. And before we go into that, let's see if there are any questions. We're all very quiet. Yes. This, as I say, is the top level of BFO. We have universals, but we also have instances. They are people's heights, people's headaches, and people's walkings. They're the instances at the bottom level. And we can think of an ontology as being like a catalog of types, and then the instances are the actual instances of those types that you find in your warehouse. And then we distinguish between the universals, which are what the ontology represents, and the classes of particulars, which are the extensions of those universals. OWL tends to run those two together, but we try to distinguish them. And so I'm going to very often be using phrases like universals or classes. That means for many purposes, it's okay to ignore that distinction. But if you get down to the weeds in using BFO, you need to have it clearly in your mind. All right, so ontologies are interested in generalizations. Databases are interested in particular instances. So scientists do experiments using instances, and they need to collect data about instances. But then their theories are about generals, not about particulars. They're about what holds in general. All right, and then that's an ontology of sorts. The first thing that you will gain if you read that book is insight into various simple ontology traffic rules. So these are the kinds of things which would be built into a wizard. The first ontology traffic rule is that to build a definition, you should always formulate it using this two-part schema. So you define a B as an A which sees. For instance, a human being is an animal which is rational. That's not my definition. It's an old one. I found it on the web. You have the term you're defining. You then have the genus, the next highest term in your ontology, and then you specify the specific difference. What is it about these particular instances of the genus A which makes them instances of the genus B? The answer in this case is that they're rational. This means that every term should have at most one parent in the ontology, otherwise this traffic rule breaks. Because if you have two parents, you don't know which is the genus, which you should be using for the definition. So there are many rules for definitions like that in chapter 4 of the book. Another even simpler traffic rule is that all the terms in your ontology should be singular nouns, which means they should be nouns which you can count. So 1 organism, 2 headaches, 3 administrations of drugs. That's because ontology terms represent universals, and because universals have instances which you can count. If you put other kinds of things which you can't count into your ontology, you'll get into difficulties. But BFO won't work, first of all. All right, and now a good clue as to whether you're dealing with an instance or a universal is that you can only take photographs or videos of instances. For universals, you have to use cartoons or lists, names, tables. All right, now, roughly speaking, universals correspond to the general term used in scientific law. The items on the left are clear examples of universals. The items on the right are clear examples of non-universals. And Elvis himself is not a universal, but the class brother of Elvis fan. It's a very large class, but it's not a universal. There's no universal contributing to it, corresponding to it. That means that there's no scientific law which could ever contain that term. And that means that while you can create an ontology which is about brothers of Elvis fan, it's not going to be an ontology which is conformant to the principles of ontological realism. You're pretending there is a universal when there isn't a universal. Similarly, there is no universal which consists of all chemicals whose names begin with B. And there are ontologies which have terms like that in them, believe it or not. All right, now, we need both continuance and occurrence because we need to say things like this. We have processes, which is the tumor developing, but we also need objects, the tumor that develops. And if we have processes, the processes will have extensions in time. So we need time regions. And so we can tell the difference between objects and processes pretty easily. If you think about it, processes have temporal parts. Objects have spatial parts. So the temporal parts of this process, everyone who's a clinician in the room can tell us what they are. The thing on the left doesn't have temporal parts. It exists throughout its career, but it doesn't have a part which is its early career. The early career is a part of its whole career. All right, so we view the world always in terms of continuance and the occurrence. It's two perspectives over the same thing. Every time we see something, we are seeing both continuance and occurrence. And continuance exists in time identically. I am the same continuant as I was 5 years or 5 minutes ago. I gain and lose parts, but I'm still the same continuant. And even if I lose an arm, I'm still the same continuant. I'm still complete. I still have all my parts. Because now my parts don't include that arm anymore. Occurrence, on the other hand, unfold phase by phase. They have beginnings and endings, which are also occurrent. All right, so you are an occurrent, you're a substantial object, your life is a process. You are three-dimensional, your life is four-dimensional. Every occurrent depends on one or more continuants. Every quality is a quality of some independent continuant. Every process depends upon some independent continuant. Every quality depends upon some thing which is the bearer of the quality. Things participate in processes. And we can define the relations that we were just using now, but this depends on and participates in. You can understand what they mean. Now we distinguish among the things which depend, first of all, qualities. The second kind of dependent continuum are roles. These things require realizations. So now I have the role of lecturer. What does that mean? It means my role is realized in lecturing. There is a process which realizes the lecturer role. So roles go hand in hand with processes. And then thirdly, we have dispositions. So I am disposed to speak with a loud voice. This is realized in speaking. First of all, we'll look briefly at qualities. So when we're dealing with qualities in the Yoga Foundry, we turn to PATO. PATO has a huge vocabulary of different kinds of qualities, such as red, green, brown, and so forth. So we have an entity, which is the particular case of redness of this particular fly eye, which instantiates the universal red. And then we have the eye, which instantiates the universal eye. And then red is a color. And so the redness of the eye is also the color of the eye. And eye is an anatomical structure. And so the eye being in a particular fly is also a case of an anatomical structure being in a particular fly. PATO also allows processes to have qualities. For instance, the quality of being beating at 60 beats per minute of your heart's beating. This is a quality according to PATO. Now this violates BFO. For BFO, only independent continuants have qualities. Processes can't have quality. Now, PATO finally is undergoing a revision in this regard so that PATO will be consistent with BFO. Let me explain the methodology here. When you find an old body of data on the web, which you want to exploit, you want to scrape it from the web and use it for your own purpose, it's often a very good idea to have restrictions on how you can understand the data. If everyone understands the data so that only qualities have independent continuance, this data scraping is more likely to be done consistently by different people. If people can choose what they call a quality, then the data scraping is less likely to have consistency. And we know this from experience. So Alan Rothenberg is a world champion data scraper. And he really likes the fact that when he's scraping data, his hands are tied to a certain degree. So what is the solution? Well, this is the problem. PATO quality extends too broadly. BFO has a perfectly simple way of treating the same information as is treated by PATO in this way. But we have, I think, reached an agreement where PATO will change the term it uses for qualities of processes to call them characteristics. So we will have PATO characteristics, which are what now are called PATO process qualities. Other qualities in PATO will stay the same, they'll still be called qualities, and there will be a new relation called has characteristic, which is the relation between a PATO characteristic and the process which it is the characteristic of. And the way BFO will treat these things now is as follows. We introduce, not as a new class or a new universal in BFO, but as an abbreviation, the term characteristic. Characteristic involves either process qualities or object qualities. And then to capture in BFO terms what's going on here, if John is running at 3 miles per minute at a certain time, that means that John has a quality at that time of running at 3 miles per minute. That's a BFO quality. Just like John has a height at time t of being 6 feet tall. John participates in a running process at t, and we can then refer to that running process as having a characteristic of being 3 miles per minute at t, which captures the PATO process quality. Now, this is a very trivial rearrangement of wording. There's no exciting rocket science going on here, but it means that we have captured the content of PATO and reworded the way PATO formulates that content in such a way it's consistent with the way everybody else uses BFO. Roles are what we call externally grounded realizables. What that means is that I have the role of lecturer because someone told me to lecture. So roles work in time. I have a role from a certain time. I don't need to change at all at that time. And then I stop having that role at a later time. But then we have internally grounded realizables. So dispositions are internally grounded. I have my disposition to sweat because of something about my physics. Something in the physical structure of me makes me gradually go bolder and bolder. We deal with all matters of possibility, potentiality, tendency under this disposition heading. All matters of causality under this disposition heading. Basically, a cause involves a disposition being triggered by something, but BFO does not have a treatment of cause. Maybe we will have down the road, but we know how to start the treatment. Now, functions are the most important. Functions are just a special kind of disposition. The thing which is physically in such a way is physically in such a way, and that is the reason for its existence. So the function of a car is to transport at least one human being. And now, it's interesting that functions are such that their realizations can be graded on a scale. So my heart can be pumping well, or pumping very badly, or I'm dead. And we'll come back to that grading on the scale later on. All right, now, so functioning is the realization of a function. And now we come to disease. So finally, I can answer the question. Your question. So diseases are dispositions. I missed the is our line here, connecting disease to disposition. It's just an example of a kind of disposition which is not a function. And diseases are realized in disease courses. And diseases have material bases which are disordered. This is the terminology that we advocated in the Ontology for General Medical Science. Now, why do we have this tripartite view of the disease phenomenon? So let's suppose we have two identical twins, both of whom catch the flu. And let's suppose that they catch the flu in exactly the same way, exactly the same parts of their airways are infected by exactly the same number of exactly equally virulent flu germs. So we have two exact copies of the same disease in these identical twins. But now we don't, because one of them starts taking anti-flu medication. We think that we need three different entities in order to capture this phenomenon